There we go. Oh, Jesus. I said you're a terrible programmer. That's what I said. All right. You guys know White Star Software. We've been around for quite some time doing all kinds of DBA stuff, complaining about programmers, fixing your code, all those natural things that we do. And I've been doing this now since 1994, which freaks me out a little bit because I remember when I started coming to conferences, and then I would see the Dan Formans and the Tom Bascoms of the world and these old guys that were there, and now I'm an old guy who's up here in the front. So what are we going to do? I'll just have some first thoughts to start, dig into some tooling, talk a little about indexing and index selection and how to improve your queries, how to find problems in your queries, take questions. If you have questions along the way, please don't hesitate. There's no need to wait until the end. If you have a comment, if I say something stupid, Tom will correct me surely anyways, but feel free. And let's go. So first thoughts. So this is always the funny thing. You always get the phone call, the system is slow, right? And you never get any details about what's slow, right? Are you trying to modify a record and it's slow? Are you trying to run a report and it's slow? Are you trying to load an invoice and it's slow? Like nobody ever explains to you what's slow, but they always say it's slow. So today we're going to try to concentrate on query, right? There's a lot of reasons why a user might be experiencing slow performance, but we'll try to talk mostly about queries. And at the end, I think I'll have extra time. I'll just talk about a couple of other things that are not necessarily query related here, all right? Good. So there's a lot of ways to find bad code. Some of you have probably instrumented, who already has some instrumentation in their application. So a couple of people, right, for finding bad code. Patrice doesn't have instrumentation. Patrice is instrumentation himself. We're going to show ProTop screens. What I'm showing you is 100% free, right? This isn't a commercial session. You can download ProTop real-time anytime. We're just using it to kind of show you some screens here and there, but all 100% free. And even the source code is included, so you can even go look at what we're doing underneath to gather the information that we're showing you on the ProTop screen. All right, so let's start. So the first thing I said was, okay, you've got bad code, you've got people who are complaining. Of course, nobody ever gives you specific details about what it is. So what can you do to go and find that there's bad code running, right? And so I'll show you just using ProTop, but you can essentially do the same thing yourself, and I'll quickly show you how to do that. So what I did was I just started a couple of programs that are doing bad things in the code that we can see are reading an excessive amount of data in the database, all right? So churn.p, we're using the sports database. I just beefed up the sports database. So churn is reading the very, very small vacation table a very, very large number of times, right? So that's one thing you'll see. And then the other one, the orders program, it's doing for each customer, each order of customer, and it's just reading millions and millions of records over and over again, just again to show you these villains that are causing performance problems in your database. So what did I do? I just popped them up in ProTop. So you can install ProTop, like I said, free, real time, and just look. And at the bottom of the screen, there's a user I/O activity panel, and it'll show you the worst offenders at the top of the screen. So I can see that the worst offenders, sorry, I don't have my pointer clicker laser thingy. So you can see that at the top, I've got this user whose name is Flail, and he's doing 1.1 million database reads per second. You got your clicker there? Which is the laser? Thanks. So you see this guy here, he's doing 1.1 million block reads per second. So ProTop always shows per second rates here. All right. And this other user, which we'll see in a minute, he's doing about 550,000 block reads per second. So now we're like, okay, I've got my culprits. I know, the report is running, the user's complaining. I know I've got this user is a problem, but what is the user doing, right? We need to dig in a little bit more to find out what the user is doing. But first, how do I get this information? They just come from the _user IO VST here. And again, you can go look at the source code for that screen that I showed you previously, and you can pull this data to see how. But it's really the _user IO VST where you find that data. Fair enough? So you scan _user IO, you can find the culprits. And if you do it programmatically, if you sample it the way the ProTop commercial product does, then every time you hit some number that's interesting, you can go dig in now and try to find more information about these interesting users. All right? And one caveat here, most of the time when we come to new customers, they haven't set table range size, index range size, base table, base index correctly. So most of the time, you're not gathering these table statistics and index statistics for all the tables for all your users. So go ahead and make sure to do that. And if you're not sure how, you can look in ProTop RT. You hit T for, I think it's T, right, for table analysis, and that'll actually generate a file called yourdatabasename.range.pf, and it'll actually show you the optimal values that you need to set it to. So again, you want to find out what the user's doing or what the program is doing. Make sure you set your table range size, index range size correctly. And you'll see when you see, I didn't do a screen capture of it, but you'll see that we suggest that you set minus base table to minus 361, minus base index to minus 1049 or something like that. And the reason we do that is because the schema tables like _file, _index, those have a negative table ID. So if you want to capture statistics on the schema tables, then you want to go ahead and set the base table and base index to a negative number. Is anybody running OpenEdge Explorer, like starting their databases with DBman? Anyone? A few people? So be careful with that, because I haven't tried it in 7 recently, but for a very long time, if you tried to set base table to a negative number in OpenEdge Explorer, it doesn't let you set it. It says it has to be greater than 0, which is not true. And then you have to actually go and set it in other args and put minus base table, minus 361, blah, 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 right? So if you see that error message, it's an OpenEdge Explorer bug, not that the number is not valid, all right? Can anybody tell me why, at least one reason, there's a couple of good reasons why you would want to be monitoring usage of the schema tables? Someone? No, you don't count, you work here. No. Okay. Go ahead, Ben.
Yeah, if there's any data indexes there.
If there's what?
I wouldn't like to have data indexes in the schema table.
No. Why would you want to monitor table statistics and index statistics for the schema tables? Like how many reads are occurring in the schema tables? Anyone? Bad code? Close. Don't Tom again. This guy's in the back. Come on. Oh, no, you have got 2 prizes. Win a 3rd prize, man. Come on. All right. Yeah. Some people use user. I don't follow. Some people use user table in queries. That's not the one I was thinking of. The one I was thinking of is if in your deployment process you accidentally don't compile R code, then in production you'll compile on the fly, and you probably won't notice this. And your users, if your users are running P code at the speed of a user, they might not notice this, but your app server agents and your web speed agents will very much notice that they're compiling code on the fly. So you'll see CPU usage spike, and in your table statistics, you'll see that you're reading _file, _index, and so on a lot more. And if you see that spike and the CPU spike, something happened on Sunday in your CI/CD process and you didn't compile your R code, for example. So that's another one. Thomas. Yeah, that was number 2. So Tom was mentioning, who's using dynamic queries now in their code, right? More and more and more and more. And so the more you're using dynamic queries, the more you're actually using underscore field, underscore file, underscore index, and so on, because you're actually compiling the query at runtime, which requires you to go and read the schema. Yeah.
I always put schema area in B2.
Bent is saying he always puts the schema area in B2. So you're right, those schema tables will be in memory, but you're still reading them a lot, right? So now instead of consuming disk I/O, you're consuming CPU cycles to read these over and over and over again, all right?
Another thing that causes some activity in those tables is when you connect to the database and start running a program, schema gets cached as part of that process. And it only happens occasionally, but it does generate some activity. So not all activity to those tables is a sign of something being wrong.
Correct. So he's saying when you connect, the client is going to cache the schema. And if you're using DB notify time and you modify the schema, then all the connected users will refresh their schema cache too at that time. And you might also notice if you're running Protop, that Protop reads this, does a lot of the benchmarking it does by reading the schema tables, because those are the only tables it knows it can find in any one of your databases. So we actually read the schema tables quite a bit just for the statistics that we show in Protop. There we go. Oops, previous, too much. All right, here we go. Okay, so what are they doing? All right, so this is pretty cool. We got the same users here. We got them. They're doing their 1 million and 500,000 reads per second here. So what did we do? First thing first, if I look at the actual table statistics and the index statistics, you're going to see is there like an airplane flying through the room now? Or that's rain? Jesus Christ. Okay. Hey? That's right. I was walking on the beach earlier, and I did manage to get back before this happened. So why is it interesting to have those table and index statistics? And more importantly, why is it interesting to know how many rows there are in a table when you're reading it? Well, here's the vacation table. It has 12 records, and I'm reading it 526,000 times per second, one user. So who would at least admit that there's a code error somewhere in there that Tom wrote on purpose, but still Tom's code, right? So if you're doing 500,000 reads per second in a table with 12 records, and we see this often with control tables, right? In every loop of a loop of a loop of a loop, you're like, find master control and then go get a value, rather than caching the master control table at the beginning of your program. So that relationship between the reads per second and the size of the table is important. If I look at the other one, which is the order table, that I'm doing 94,000 reads per second in, well, it has 727,000 records. Okay, still not acceptable. I'm reading the entire table every 8 seconds, essentially. But still, I can see that relationship. And why? It's because when you're coding and when you're doing this kind of benchmarking in your test environments, if you're reading GL detail that has 942 million records and you read 100,000 of them or 1 million of them, maybe that's acceptable, right? It's normal. That's the range that you think you should be reading. But if there's only 12 records in the table, you better not be reading it 100,000 times per second, or you better have a really, really good story to tell me about why you need to read 12 records, 100,000 times per second. And then the last thing I'll show you here, and maybe the most important one, is client statement cache. So who is using client statement cache today? So the rest of you, really, you should think about using client statement cache, and I'll talk about it a bit more here. But client statement cache is cool for a couple of reasons. Really, it tells you the program and the line of code that the program is currently at when you sample the VST, all right? And we tell you how old, in Protop, we calculate how old that client statement cache is. Why? Because If this was 15 seconds ago when I sampled it, maybe I'm not there anymore, right? Or maybe the reads I'm doing depends on the granularity of my sample, right? So you're kind of in the vicinity, but you may or may not be exactly at the right line, for example, all right? So watch out for that. But still really, really cool to be able to just, in your own instrumentation, ProTop does it, but really easy for you guys to add it to your own, to be able to see the program and the line of code of the user at that time. And we used to be scared to turn it on because there is some impact. Today, I'm not really scared to turn it on. And there's maybe 3 exceptions to that. Exception number 1, for client-server connections, I think the cost of client statement cache is still pretty high. So be cautious if you want to enable this in client-server connections. You can still do it, but maybe only for temporary periods of time. Number 2, if your CPU is already here, this will add a certain amount of CPU work on top of what you're already doing for shared memory connections. So again, if you're already at 95% CPU, don't turn this on for all of your users, all right? And then the third one I would say is if you have like a lot of users, like 2,000 users, then I would be cautious also about turning it on. And again, depends how fast your CPUs are and then how much extra CPU, idle CPU you have. So be cautious. But I would say today we're more and more often just enabling it all the time for everyone all the time because the modern Xeon processors can handle it, and we don't have that many customers that are already running at like this CPU. Yes?
If you are running like this, one of the easiest ways to find out why is to turn on.
So Tom said, if you are running like this, one of the easiest ways to find out why is to look here and turn on client statement cache to find out who the offending user is, right? Or at the very least, if you open up like top or nmon or whatever, and you find there's one PID that's using, or 2 PIDs that are using massive CPU, _progress PIDs, then at least you can go in and maybe just turn on client statement cache for those 1 or 2 users to figure out what those 2 users are doing, for example. All right? So a couple of things here. You can do this from the _connect VST. So you can do it again programmatically, right? I would say always use option single. What is that? That's 3, I think, right? That you set it to for single? Or do you remember the number? Okay, but watch out for that. But make sure that the value you set to _connect caching type is the number that's equivalent to single. And what that means is it just keeps 1 in memory, all right? Top of stack. Yes, single. No, that's one time. Well, we're using the same term. One of them says that it only keeps the last command in memory. One of them says, I'm only going to get 1 time, and then I'm never going to get it again. And then the last one says, I'm going to keep a history. No. Yes.
No, not history. It's the full stack.
The full stack.
You're saying the same thing different ways. Last command in memory is not the thing. That would be a one-time sample. But what you want is the top of the stack, so you don't have all the programs
Correct.
to get there. That's what you're calling single. That's top of stack.
All right, top of stack. Top of stack.
Yeah, so what that does is it tells you that one entry, but it keeps sampling. It doesn't
Right.
sample all at once.
Continuously do that.
I have to work with these guys. I just have to tell you. One important note, when you enable client statement cache, it's forward-looking. So if the query is running right now, and you're like, oh, what's that? Let me enable client statement cache. It won't tell you because it's too late. That query is already running. So if you want to look in the past, you do pro-get stack on the PID, right? So if something is happening now, client statement cache isn't already on, then do a pro-get stack and then go through the protrace.pid. And that's why I tell people, again, just enable client statement cache all the time with all the caveats that I mentioned earlier. And that way you always have that top of stack. You always have the top of stack available to you. All right? Whew. All right, so tooling. So this is great. Now you know how to find, excuse me, some offending users, right? They're using you can see that they're hitting a certain table a lot with client statement cache. You can go and see really what the query is. But even if you have the query in front of you, you want to say to yourself, well, okay, what do I do with this query, right? So you can integrate some tooling right into your code. And one of my favorites is Log Manager. And the reason I like Log Manager is because when the user calls you and says, I'm running this report and it's really slow, you can put some hotkey secret sequence in your application where they do Control Alt, I don't know, whatever, something, or they do help turn on tracing, which essentially runs this one command, excuse me, and enables tracing, right? And the one we really want is query info. So 4GL trace will tell us where you're running through in the programs, so you can see in what program they're running, and then query info will give me information on the query that's being executed, all right? And of course, I have to remind people that a find is not a query, right? So finds will not be caught by this, and finds are often very bad culprits in terms of reading more records than you expect them to read, but that's another story. All right, so you turn this on, or you tell the user, do this hotkey, which runs this code, repeat whatever it is that you were doing. When they finish, they do the hotkey again to disable this because you don't want it to run for their entire session, and then recuperate the output, and the output's going to look something like this. All right, who's already using this stuff? Who's a few people? Okay, great, cool. So for the rest of you, so what's really cool here, a couple of things. Of course, you know the program and everything, and he's telling you that the query's on line 9 of paulorders.p. But what's really, really cool is he tells you that you did 200,000 reads in this table and 200,000 reads on this index, and same thing for the order table and that cust order index, all right? Now, if you're on an older version, I don't remember when they fixed this, but for a very, very long time, it would put unavailable and unavailable for the index values. I don't know if you guys have ever seen this, but so that's pretty much fixed now. I think I was doing my tests on 12.2 something, essentially. But it's really cool, again, you run the program and you know exactly how many total reads they did, and you should, again, as a programmer, logically know what that number should be, right? And so if this number is much higher than what you logically think it should be, then, well, there's something you got to fix in your code, clearly, right? And it gets cooler because I can compare, did someone say something? Sorry. I can compare database reads to record reads, right? And again, there's some expectation that they kind of somewhat match, but if they don't, that could point to other problems, right? So if my database table reads are much higher than my record reads, maybe I have fragmentation. So I'm reading more than one record, one block in the database to extract a record, for example, right? And I expect typically that I'll do more index reads here than I will do, where are they? Here they are, like 727, oh, maybe not. Oh, here you go. So index, you can see here, I did 928,000 database reads for this index, but if you look over here, I only got 727,000 odd records, and the reason for that is you might have a multi-level index, so you might do more than one index read as you're traversing the index to get the keys to go get the record that you want, okay? But again, if this number is hugely higher, then maybe it's time to compact your index or rebuild your indexes, for example. So another useful indicator here that you can pull from this, in addition to kind of the classic reason why we're talking about this, which is that, 727,000 maybe is just too big a number for what you want. This way, cool. And then the last thing I'll tell you that's really cool is it might tell you that you read 200,000 records, customer records out of the database, or database reads, but you only read 28 records. So that's telling you, maybe there's something you're doing here that isn't quite right, right? So I pulled 200,000 records, but really to satisfy my query, I only displayed 28 records. So something's wrong. Your query search is much wider than the number of records. And can anyone tell me why this happens? Sorry? Index, right. So if you're doing an unindexed read or an incompletely indexed read, you're going to pull the records from the index, and then after that, you're going to extract the records that you want. So the items in your where clause that are not part of the index are ending up being filtered by the client itself, essentially. All right. So tooling number 2 is equal. I like to talk about this one because it's fun, though it's a little bit hard to use in the real world. Has anyone ever played with this equal parameter? Just for fun, a couple of people. This is a fun one. The reason I say not to use it in production is because it writes into the database log file. It doesn't happily write into some side log file. It writes right into the database log file. But the reason why this one is cool is not only does it tell you which index you're using, it tells you how deep you go into that index. And sometimes, we'll talk about index rules in a little bit, but sometimes people misunderstand how index selection works. And not only index selection, but which of the fields in the index are actually being used. And so this will tell you definitively how many fields in the index you're going to use. So for example, and it'll show you, you'll see the numbers in just the next slide, but what it does is it says, this is how many lower bounds you have, and this is how many upper bounds you have. And what does that mean? It means if you say, find customer where customer.name equals Bob, an equality is both an upper bound and a lower bound, right? It's greater than or equal to Bob and less than or equal to Bob, so it's equal to Bob. So that's a range on the lower and the upper side. If you say greater than or equal to Bob, then that's a range on the bottom. And if you say less than or equal to Bob, then that's an upper range, right? You're limiting where your query is going, but limiting it on the upper side. So it'll show you the range, and then again, how many tokens in the index, how many fields in the index you're actually using. So here's an example, right? If I say for each customer, no lock where city equals Bellevue, there is no index in the sports database that starts with city. In fact, there's no index that uses city at all. But again, you always have to start from the first token, the second token, and so far the index. So what does this tell you? It says you're using index number 15, and I'll show you how to find what 15 is in a minute. And you're doing 0 upper bounds and 0 lower bounds. And if you're reading a table with no boundaries, no upper bounds, and no lower bounds, it means you're reading the entire table, right? From beginning to end, and then filtering out all of the city equals Bellevues, for example.
And it's really fast with small tables.
It's really fast with small tables. So if I say the same thing where country is greater than A, so if I say it's greater, then that means I'm setting a lower bound. And here it's telling me I'm using index 17. I have 1 lower bound and no upper bound. So what that's telling me is I'm using 1 field in the index, which has to be the first field. So for those, I say it later, but just to repeat it here first, you always have to use your index fields in the order. So if your index is field 1 and field 2 and field 3, if you say for each blah blah where field 1 and field 3, well, you can scrap field 3. It won't be used in the query at the index level because you forgot field 2. It'll use field 1, and that's where sometimes people get a little confused or trapped in terms of why they're doing more reads than they think they are in the database. All right? And then you can see here, for example, where country equals A and postal code is greater than 100, where I can only do 1 range match at a time in an index. That's one of the rules. So again, it's telling me 1, 0. But in the third one, where I do an equality match, country equals Austria and postal code equals 100 or greater than 100, here I can see that I'm using two lower bounds because the equal sign is a lower and an upper, and the postal code is a lower bound. So I've got two lower bounds and one upper bound. And again, the higher these numbers are, it means the more components of my index that I'm using. Did everybody understand that? You have to play with it yourself to go see it in action to see what it does. All right? How do you find out what index 15 or 17 is? Simple. You find the file, find underscore file, where underscore file name equals customer, and then find underscore index of underscore file, where index number equals 17. And then in this case, it's country post, country plus postal code. It's not a query. So there's no information about this request in the database log file. All right? And you can combine the two. It's interesting, right? So if you take the query info stuff that I showed you earlier in Log Manager, and you take this equal stuff to show you how many records or how many fields you're using in the index, and you combine the two, and it kind of makes sense to you. You realize that, oh, I'm only using where company name equals this company, and then you're doing essentially a table scan of all the GL records for the company because you're not filtering on the second field and the third field and so on and so forth of the index, all right? And it's another reason why we see this all the time. We go to customers and they have an index on A plus B plus C, and then they have an index on A plus B, and they have an index on A plus B plus C plus D, and you're like, why do you have 3? All you need is 1, and we'll use the A, B, C, D index. You don't need all these redundant index. But how many people have ever deleted an index from their production system before? Liars, all of it. I've never seen anybody, oh, but there's what if there's code that uses it? It'll crash and you'll find it. There you go. All right. And method number 3. So this is the one you probably learned in your beginner programming class. Whoever does compile xref and looks at the search values, right? Me, I'm not a huge fan of this particular method. It does tell you which indexes you're using, which is good, but it doesn't give you much more information than that. And of course, like I remember when I first learned about this stuff, they said, oh, look for a whole index. But even looking for a whole index is misleading, right? Because like if I take this one and I say for each customer where name is greater than blank, that's a table scan, but it's not going to show up as a table scan in the xref. So it's a little bit misleading to this. So again, not terrible. You can see which tables and indexes are being used. And we have customers, I don't know if you guys do this, where they use the compile xref to build a, a cross-reference about which programs are you which tables and which indexes. So that way they know if they want to modify a table or an index, they know which programs are going to be affected by that change. So that's a good use for it. But now even with dynamic queries, you can't even know because you can do so many things dynamically anyways. Cool? How am I doing on time? I'm doing okay. What time did I start?
1:45.
Oh, okay, I'm doing all right. Cool. Good. And then the last one, and I'm not going to go in detail on this, who uses the profiler? That's great. Excellent. I love it. Yeah, so this is a great tool, especially since they integrated it into Developer Studio. For the longest time, it was unsupported. Someone doesn't use Developer Studio. And you can easily write your own code to grab this. We have some example code that we use for enabling Profiler outside of Developer Studio and then parsing through the output to create a graph like this. But the cool thing about the profiler is it tells you how many times that line was called and then how long it took to run that code, total over the life. So you can easily see, oh, I run this report that runs other things, and I can see that 99% of my time is spent on this one line of code. You can right away see where you need to go and optimize your code with Profiler. But glad to see that everyone's using it already. All right, so what's next? You found the offending code. We saw a bunch of tools that are available to you for identifying the problem, right? We need to improve it. And what does improving it mean in this context? It means reading less records, all right? And how are we going to do that today? We're going to kind of look at about these index selection rules, all right? Who's seen us? I mean, the last time we did this, I think, was in 2018. Has anybody seen any of my talks that we did before COVID on a couple of people here? So really, we really want to make sure everyone understands these index selection rules properly, all right? An important thing with what I'm going to show you about the rules that I'm going to show you eliminate indexes. They don't select indexes. And this is another misconception that people have, right? They say, oh, we're going to apply the rule, and that rule is going to say which index we're going to use. In fact, the rules are parsed, and then any index that doesn't conform to the rule is discarded, and then the remaining rules are then fed to the next, the remaining indexes are fed to the next rule. Any indexes that don't pass the rule are discarded until eventually you're left with one index, and that's the index that's selected to satisfy your query. And of course, there's exceptions, and I'll talk about those in a minute. All right? And here I am saying it what I said earlier. Field match rules must be contiguous. So again, if you have an index on A and B and C and D, if you want to use C, you have to use A and B in your where clause. You can't say where A equals this and C equals that. They have to be contiguous, which means that the index will only use A. It cannot use C because you didn't use B in the middle. All right? Good. The rules. The first rule is actually a pre-selection rule. So at the very least, the first thing it does is it pre-selects any indexes where the first component of the index is in your where clause. So right away, whatever, X% of your indexes are eliminated right away in the pre-filter. The first component of the index must be in your where clause. Otherwise, it eliminates those indexes. So now we're left with, whatever, we had 5, now we're left with 2, I don't know, for example, all right? The next one, if the where clause has the word contains, we're going to use a word index right away. So forget all the rest of the fields, we're going to use a word index if your where clause has the word contains in it. Next, unique indexes with all components involved in the equality match. Can anybody tell me why that's one of the most important rules? Simple answer. A unique index with all equality rules. Before I go to Rob, come on, guys. Come on. All the Baltic Amadeus people, come on. One record, right? If you have a unique index and all of the fields in the unique index have equals, you're going to find 0 records or 1 record because it's a unique index. All right? So we'll look for them. Are there any unique indexes that have all the things? Okay, this one, yes. You can have more than one. It's possible index. What? If there's a... Yes. But that's at runtime now, not at index selection, right? We don't care. We're selecting and eliminating indexes. So if we have equalities equals question mark, for example, then that'll filter out those and then filter out the rest of them. So now again, if you do happen to have this, typically it'll be the only index left that didn't get eliminated, and so that's why it gets selected at this point, that unique index. All right? After that, it's the most active equality matches. But I say sort of, kind of, because when we were doing all our benchmark testing, there always seemed to be some edge weird case where it didn't quite match these rules. But really, it's most active equality matches. And full matches, I said trump partial matches. But if there's one field, we saw some weird behavior here. So sorry, I'm waving my hands a little bit because, again, I don't have the source code to the compiler to understand exactly at this point how it selects those. All right? But again, under normal circumstances, the ones that have more equality matches will remain. The ones that have less equality matches of the fields, contiguous fields in the index, will get eliminated out of here. And again, keep going down. Most active range matches. What's a range match? Greater than or equal to, less than or equal to. So if you have any kind of range match, that will help select, again, filter out indexes. And finally, the sort. So if I still have 2 indexes left that have satisfied all of the other rules, and at the end it says by customer number, then that will pick the index. All right? Now, it's possible that I went through all the rules and I still have more than 1 index left. So what does Progress do? If he says, well, we passed all the rules, what do I do? First thing he says is, I'm going to use the primary index, if it's there. But you might have already eliminated the primary index for whatever reason. And this is my favorite one that most people don't know. If all else fails, he takes the first index alphabetically by name. All right? And in temp tables, it'll take the first index by order of definition if it hasn't been able to find an index from one of the other rules. So watch out for that. And the reason I tell you to watch out for that is because you might have in your code that runs through all the rules and ends up picking the first index by name, and then you add a new index with a name that sorts higher, and all of a sudden that code will run with the other index. So consciously, you should know in your queries which index you expect to be used and make sure that that index is being used in your queries. Too bad. Cool. So here's an example. For each order where order number equals this, or order number equals this, and custom equals another number, I did just give you here quickly the indexes that are defined in the Sports 2000 database. So I have here an index on order number. I have another one on custom and order num, for example, here. And so if I say for each order where order num equals 1, 2, 3, 4, 5, okay, you're going to say to myself, all right, if I go back through my rules, I'll say, okay, leading components, great. So who has order num and custom as a leading component, one or the other? So I'm left with this one, this one. This one's eliminated, this one is eliminated, and this one is eliminated. So I'm left with 2 possible indexes here. And I say, okay, is there any contains? No. Is there a unique index with all components? Okay, yeah, I have a unique index here with all the components. This is also a unique index with all the components of the unique. So I still haven't deselected any of these 2. So I go to the next one. Crap, I can't do previous. All right, most active equality matches, and this is where it gets fuzzy, because here I have 2 equality matches, 2 out of 2, and here I have 1 out of 1 here for the thing. So it could pick either one of these indexes and it would be correct essentially. But if it, again, I think it'll select this one because 2 matches is greater than 1 match, but I'm not sure it'll actually do that. Again, because of this fuzziness that I don't understand here at the selection process. All right? And then last, okay, range matches we have none, sort matches we have none, and then we default on the primary index. So I think this one here should pick cust order because there's 2 equality matches, but it might not eliminate this one and then end up picking this one because it's the primary index here. All right? So again, I'm just being honest with you, there's these fuzzy rules here that, again, we never were able to lock down exactly what they were. But I did another example here for you guys. So again, here's sales rep and order status. So you can see I have a non-unique index on sales rep and I have a non-unique index on order status. What is my The question is, what is my comments on use index? My comment on use index is you should not use index. So, and if for whatever reason you absolutely have to use index, there should be like a 75-word comment above the query that explains to the next programmer who's going to call you an idiot for using use index, saying why you had to use index in this particular. Because then the next programmer is going to come in, he's going to say the last programmer was an idiot, and he's going to remove the use index, and the code's going to break because you did it on purpose. But if you did it out of laziness, then that's not a good reason to use index. Yes. If you say use index, then there are no rules. You told them what index to use. So, who uses use index now that I insulted people who use Yes.
The other thing about use index is that it uses v6 query rules, so you lose the ability to have multiple indexes resolving a query.
And I'll talk about it. So the comment is, if you use index, then you're using v6 query rules, which means no using multiple indexes, which is exactly what this slide is here. Because you're going to pick just the one index because you told it to use the one index.
Or even multiple cursors on one.
Or Sorry? Exactly. And you can't use multiple cursors in your query. But yeah, so he says sometimes it's faster because when you're using two indexes in a join. And again, I'm not saying you should never ever use it. I'm saying that if you use it for a specific reason, explain it in your code, because he's going to come after you and he's going to erase it because he's going to say, oh, this junior kid was lazy and he put use index in his code. All right. So here's an example to Rob's point where two indexes get picked, right? And we showed this grid method. It's a good way to think about it, right? So pre-selection rules says only show me, indexes where you have sales rep and order status. Now we had created some other indexes here just for fun. These don't exist in the standard Sports 2000 database, but you can see here the order status and the sales rep are pre-selected. Is there a contains? No. Okay, so we didn't eliminate any indexes here. Okay, is there a unique index with all components? No, because neither of these indexes are unique. Okay, do we have a quality match? Yes, we have a quality match, all right? And then no range matches, no sort matches, and we end up using both indexes here, all right? And why do we do that here? Because Progress will use multiple indexes in two situations here. One, if you have an AND, if both sides of the AND are using all the fields in both indexes, all of the fields with equality matches, then Progress can use the two indexes and then combine the results at the end, all right? And then the second one is an OR clause, and I'm going to talk a lot more about OR clauses in a few slides. But generally, you can see if both sides of the OR contain at least the leading component, then he can use multiple indexes. And the reason why that happens is as soon as you put an OR, Progress actually treats the two sides of the OR as two separate queries and applies the rules to each side of the OR separately as if they were two independent queries, and then at the end it combines the results. All right, and we'll do that in a minute. Oh no.
I'm always wondering why Progress can't combine two indexes and one, why all components have to be matching to use both indexes. Why can't we just use two subsets of two indexes, overlap them and select correctly?
So the question is, why does the two index selection not work when it's not all the components of the index that are being used? And I have no idea. You would have to ask the engine team why.
It seems like a very easy thing to do. Yeah, everything seems easy from the outside, but it makes
Ask Tom how many easy things I ask him to do. That's easy. Just put it just do it. Just code. Yeah, I mean, I wouldn't be surprised if you went into their, product enhancement list. It's there. It's been there for about 14 years. And when they sit and they do their sprints, it just never makes it into the next release, for whatever reason. It's just not important enough, so. But mind you, if one of the engine guys would hear, maybe there's an actual technical reason why that's difficult to do, but I don't know. Sorry. Yeah. Well, the number of records is never guaranteed. It's a query, right? It's going to, whatever the query satisfied. They're telling you that there's no guaranteed order of how they're combining the records. There's no fixed algorithm to combine the records and then present them to you in a specific order. Where's Rich Banville? Complain to Rich Banville. Yeah, sorry, I don't know why. I mean, that's how it is. They'll satisfy the two queries. The two result sets will be in whatever order they were of the index, but then the algorithm that combines the two, I don't know how that algorithm combines the two and decides what order they're presented in.
In any case, you have to ask the 4GL guys about that, not the database guys.
All right, sorry, you're right. The 4GL, you have to ask the 4GL guys that. All right? All right, a couple of things. Expressions break bracketing. So the minute you add a language element like month of or substring or something like that, that has to occur on the client side. It's not occurring on the query resolution side of things. So the minute you do month or substring or whatever, you're effectively removing that token from the where clause. So that whole month of order date equals 1, it's as if it doesn't exist at all in the where clause. So please don't do that, right? Do your query on the order date itself, for example, right? And then maybe inside you can go and in your loop, you can go and check the month and do whatever you want. But this is not helping you at all by doing month of order date in terms of the size of the query. Stop notifications. Leave me alone. But begins does not break a bracket because begins is essentially greater than or equal to whatever letter. So begins does not count as something that breaks a bracket, all right? Matches does, and the temp tables rules I mentioned were slightly different, principally that in terms of the index selection, it's not alphabetical at the end. It selects the index is in order if it happens to have many indexes available.
The reason that happens is because the temp table definition doesn't have an underscore index table to establish alphabetical order.
Right, so the comment is, the reason for that is that the temp table definition doesn't have an index on the indexes in the temp table definition, so it picks them in order that they're created as opposed to alphabetical order. All right, I'm almost there. Special case OR, I mentioned this earlier. If you have an OR statement in your query, each side of the OR is treated as a separate query, and the rules are applied to each side of the OR. And then at the end, when both separate queries are satisfied, then the two are joined together, union together to give you a result set. Again, the order is not guaranteed. All right? So whenever you see an OR, you say this part here, that's a query. This part here, that's another query. They're going to be evaluated separately. All right? So here's an example. It shows here. So I said for each order where order status equals ordered or the sales rep equals BBB, and you can see that I'm using here, I did 378,000 reads in the order record, and I did 334,000 reads in the order status index and 81,000 reads in the sales rep index, right? Because I ran both queries separately and then combined the results at the end. And then this is what it looks like if you did this in Log Manager Query Info, you get the same information. So it says I did this many database reads for the table and for the index, and then here's the equivalent actual records that I read from the database. But giving you the same information that you're using both indexes to satisfy your query here. Oh, I'm going too bad. Oops. And table scans. So everybody's been taught that table scans are bad, but the reality is if you're going to read more than about a third of the table anyways, just read the whole table, right? Just read the whole table. So unless the order in which you read the table is important, then just table scan the entire table. Now you need a type 2 storage area to use the table scan option, but if you use the table scan option, you eliminate all the index reads. So what's more expensive? Is it more expensive to do index read, table read, index read, table read, index read, table read, or to just run once through all the table, pick out the ones that you want, do the calculation or the report that you want? You'll probably do less. Again, once you pass about a third of the size of the table, you might as well just read the whole table. All right? And again, it has to be in a type 2 storage area. In 11 or later, thank you, yeah, in 11 or later. Good. So just to wrap up here, I wanted to take a couple of minutes. I told you guys earlier, if I had time, I was going to take a couple of minutes just to talk about some things outside of queries, and that's client-server performance, all right? The 4GL is a very chatty protocol, I'll call it, for client-server communications, all right? Very, very chatty, back and forth and talking. But there's a lot you can do with parameters and with your code even to reduce the chattiness between the client and the server. And especially now as we go to these more distributed architectures where the database is sitting alone, and then you've got PAS-OE, little PAS-OE instances, load balanced and connecting in client server, this becomes more and more important for you to reduce the chattiness between the client and the server to improve performance between the two, all right? So one thing to remember is that Progress has a concept of messages. So when the data is sent from the server to the client and back, they call that a message. And why we have a message buffer size that we're going to talk about. And don't mix up the Progress message buffer size with the MTU, which is that network kind of message buffer size, that maximum transmission unit, all right? So what can you do? Well, you can use no lock, right? So if you have old lazy code that doesn't specify no lock, then it defaults to share lock. What that means is that you're sending one record per message across the wire. So we can't pack 10, 20, 30 records into a message. If you're share lock or exclusive lock, one record per message. So make sure you're using no locks. And use field lists, right? If you have your average record size is 400 bytes, but you only need the customer name and, I don't know, the balance, then only send the customer name and the balance across the wire. Don't send all the other fields, because again, that's chattiness that you're doing across the wire for nothing. So reduce your chattiness by using field lists and increase the message buffer size. And it's a little counterintuitive because the default MTU on the network is about 1,500 bytes. So you would think that increasing the Progress message buffer size above 1,500 shouldn't make a difference because the TCP layer has to break it up. It's not true. The TCP layer is more efficient. So you should be using a message buffer size of at least 8K. And some people just say set it to the max of 32K. But really, like when you look at, when I've done benchmarks, once you hit 8K, you've gotten like 95% of your performance. Then 16K, you're at 99, and then the line kind of flattens out above that. So set your message buffer size to 8 or 16K. However, if you're on 11.5 or earlier, the client and the server both have to have the same -mm. From 11.6 something and on, the -mm that you set when you start the database is the one that's used by the clients. You had a comment?
Yeah, which is if you set the message buffer size to 16K, let's say, that does not mean every message is 16K. That's just the maximum. So if you have a shorter message to send, it's not going to send all 16K.
All right, so great point there. What he's saying is that is the maximum size of the message. If you're sending a smaller message, then a smaller message will be sent. You won't send 16K of empty space if you're only sending one record. All right? And use the prefetch parameters. Who's using the prefetch parameters already? So all the rest of you, just go turn them on. There's no cost to using the prefetch parameters. And I don't list them all out here, but come and see me afterwards or email me. There's a white paper on this that was done. But set your prefetch parameters. Really, the goal of the prefetch parameters is to cram as many records as possible into one of those no-lock queries so that every message has 10, 20, 30, 40, 50 records in it. The default is 16 if you don't set it. So you could be sending less records per message, being much less efficient if you don't set these prefetch parameters. And then the last thing, which I'm just touching on briefly, you're in OpenEdge 12. You can take advantage of server-side joins. And then I think one of my talks I have to look at now with 12.8 comes out, talk about really benchmarking server-side joins versus 11 with the single-threaded underscore mproserve, and really trying to get a feel of how much of a gain, other than the rocket ship movie that Progress showed us, but really doing some benchmarking to look at those numbers. Yeah?
Use minus NL in development and build.
Use
Start option.
minus NL?
NL.
No lock?
Yeah.
Why?
Then you have to code explicitly lock when you're going to update.
Okay, so he says use minus NL to force you to use exclusive lock when you update, because there's no default share lock. Got it. All right. So I'm not a coder, so that's the comment from Bent there. All right, and I think this is my last slide. SQL doesn't care about anything that I just said in the past hour, all right? So none of it accounts, not message buffer sizes, not prefetch, none of that. None of that counts in SQL. SQL has its own cost-based optimizer, its own way of doing things. You have to do update statistics because the cost-based analyzer uses the statistics to satisfy the query and select the indexes. The question I always get is, how often should I run update statistics? You only need to run update statistics when, I call it the texture of the data changes. What does that mean? Like the layout in a particular index changes. When does that happen? When you purge data, right? If you purge 1999 to 2009, your statistics are no longer valid because 10 years of data is gone. So rerun update statistics. Or if you mass load, right, you acquired a company and now you just mass loaded 10 million GL records, right, you need to run update statistics. But other than that, maybe run them quarterly or something, just, you know, to refresh them. But otherwise, there's no real need to run this every week or every month or anything like that. All right? 2 minutes over. That's not too bad. Questions? Questions before we go see the curse of deleted key placeholders? Yeah.
You mentioned SQL. It's only for shared memory clients.
SQL is only for shared memory clients, is the comment. I did not know that. Mind you, I never tried it either, so. Questions? Anything? In the back.
You just mentioned the field list,
Yeah.
right? We use it sometimes in code, and isn't that? I never find any evidence of a better performance using the field list. Could it have something to do with the buffer size there? Or?
So the comment is, okay, what's that? I'm done. Sorry? Okay, so I'll give the question and I'll let Tom answer. But so the question is, I have already coded with field lists and it doesn't make a difference. Is this all made up? Is it fake news? Is Trump in the room? I only say the word Trump to get him all angry and stuff so he can answer. So let me repeat it for the record here. So what we're saying is the whole point of the prefetch parameters is to be able to cram more records into a message buffer in client server. And the default is 16. If you set field lists, so you're only sending 2 fields across, and you didn't set the prefetch parameters, it doesn't matter. You're only going to send 16 records per message, whether you're sending records this big or this big. But if you set your prefetch parameters so you can cram 1,000 records into a message, now all of a sudden you can put maybe 150 of these little small field lists into one message. So much more efficient. And I have benchmarked this, and I have seen quite a big difference when you have field lists with prefetch numrex, prefetch factor. It does make a huge difference in client server, of course. You had one?
You showed earlier a query on order, and you listed the two possible qualifying indexes.
Right.
Even though one of them brackets on two fields, it might be a smaller result list, it actually selects the single component index in that case.
So the comment is when I was a little unsure about whether the two component index or the one component index will get selected on the order query, which one is going to be selected. Are you saying?
I'm saying in that case you showed.
Yeah.
It's the one component index that got selected.
Why?
I don't know.
Oh, so same thing. Because it's the same thing. I don't know why one gets selected, but certainly it has nothing to do with how much data, right? The engine the rules-based engine will pick the same index against an empty database versus against a 10 million row database, right? Because it's a rules-based engine, not a cost-based engine. They were both unique in that case. One was PU and the other was U. So if anything, if they both ended up getting selected or not eliminated, then the primary will get selected because of the order of the things. So that's where I'm a little wishy-washy about that. And I'm out of time, sorry. So come and see me after if you have more questions. Send me an email. Thank you for being here. Appreciate it. Let's go see Patrice. Oh, and go get, look at that. Heather brought the swag all here on the table. So please, you're not allowed to leave until you grab something from the table in the back. Please grab multiple things from the table in the back. Thank you.